Hi dear students of plus 2 medical and non-medical respected teachers. उम्मीद है सारे ठीक ठाक होंगे, चढ़ती कला च होंगे। सो आज का टॉपिक बहुत ही इंपॉर्टेंट है, इलेक्ट्रिकल कैपेसिटेंस, जिहड़ा कि इलेक्ट्रोस्टैटिक्स फर्स्ट यूनिट का लास्ट पार्ट है, इलेक्ट्रिकल कैपेसिटेंस। So we will discuss electrical capacitance. Let us start. First of all, what is the definition of capacitance? Simply, or electrical capacitance. Now we know that when a body is charged, its potential increases. So if Q is a charge from the body, V is the potential of the body. So Q is proportional to V, or Q is equal to CV, or C is equal to Q upon V. So where C is called constant of proportionality and it is known as electrical capacitance. So electrical capacitance is defined as the ability to store electric charge. Ability to store electric charge is known as electrical capacitance, and mathematically it is defined as the ratio of charge to potential. Now units of capacitance: if Q is equal to 1 coulomb in AC system, V is equal to 1 volt in AC system, then C will be equal to 1 farad. So unit of electrical capacitance is 1 farad. So we can define 1 farad. So electrical capacitance is said to be 1 farad when 1 coulomb of charge produces a potential of 1 volt. It's very simple. Now let us try expression for electrical capacitance of an isolated spherical conductor. Suppose we have an isolated spherical conductor of radius r. Let Q be the charge on the spherical conductor, because charge always reside on the surface of the conductor. Then we know that potential V at the surface of the spherical conductor is given by V is equal to 1 over 4 pi epsilon naught Q upon R, or this implies Q upon V is equal to 4 pi epsilon naught R, and by definition Q upon V is nothing but capacitance. So C is equal to 4 pi epsilon naught R. So this gives an expression for electrical capacitance of an isolated spherical conductor having radius r. It means capacitance of spherical conductor depends upon the radius of the conductor. More is the radius of the conductor, more is the electrical capacitance. It means if we have to produce an isolated spherical conductor having capacitance 1 farad, then R should be equal to 1 over 4 pi epsilon naught, and which is 9 into 10 raised by 9 meter. It means for an isolated conductor of capacitance 1 farad, radius of conductor should be 9 into 10 raised by 9 meter, which is very large. It is about 1500 times the radius of Earth. It means we cannot construct an isolated spherical conductor having capacity 1 farad. So it means we have to make some other device if we want a capacitance of more capacity. So it is very important question, why an isolated conductor having capacity 1 farad cannot be constructed? Because if it happens, its radius will be more than radius of Earth, about 1500 times the radius of Earth. So it is impossible. So what we have to do to increase the capacitance? So for that we use a device which is known as principle, which is known as a capacitor. So let's understand the principle of a capacitor. So we'll understand the principle of a capacitor, how this device increases the capacitance. So for that, suppose we have a metallic plate P which is positively charged. Charge always resides on the surface of the conductor, both sides. So suppose this positive charge plate P. Then bring another plate Q, similar plate Q, close to the plate P. Then due to induction, inner surface of the plate Q, this plate Q was initially uncharged. Plate P is positively charged, plate Q is initially uncharged. When this plate Q is brought close to the plate P, inner surface of the plate Q acquires negative charge by induction and outer surface acquires positive charge. Total charge on the plate remains 0. But inner surface become negative, outer surface become positive. Now, what will happen? Negative charge of plate Q will tend to decrease the potential of plate P. Whereas positive charge of plate Q will tend to increase the potential of plate P. Because positive charge or negative charge affects the potential. Now, since negative charge is close to plate P, then positive charge of plate P. So it means net effect of negative charge will be more than that of positive charge. So as a result, net potential of plate P decreases slightly. So when potential decreases from this equation number 1, capacitance increases, the charge is the same. So it means by bringing this plate Q close to plate P, we have increased the capacitance. This is in figure 1. Now, in figure 2, if we have to increase the capacity by more amount, when plate Q is earthed, so means it is at zero potential. So this positive charge of plate Q moves to earth. But negative charge doesn't move because it is bound with the positive charge of plate P. A positive charge of plate P there, इन्हें जान नहीं देगा negative charge में. इतना bound है. So now only negative charge remains. So potential of plate P decreases further. Due to this negative charge, potential of plate P decreases further. As a result, capacitance increases. So it means we can increase the capacity by using this type of device. If we have to increase the capacitance by more amount, we can use a medium, maybe conducting medium or dielectric medium between the plates P and Q. So when conducting or dielectric medium is used between the plates P and Q, capacity of the device increases by huge amount. So such a device which is used to increase the capacitance by huge amount is known as a capacitor or a condenser. So this is how condenser is used and this is the principle of condenser. I think तो सारा समझ आ गया होगा. Very important. Very simple way I have taught principle of capacitor. Okay. Now we have studied capacitance, units of capacitance. We have calculated capacitance of an isolated spherical conductor, and this is the principle of a capacitor. Now, what happens when number of capacitors are connected in series? Simple. Suppose 3 capacitors C1, C2, C3 connected between A and B in series. Let V the potential difference between A and B, and A is positive and B is negative. Then the left plate will be positive, right plate will be negative by induction again. Let C1, C2, C3 be the capacitors of individual capacitors. Q, charge on each capacitor will be same. When they are in series, charge on each will be same. Charge is divided equally. So, but potential difference across individual capacitors will be different. Let V1, V2, V3 be the potential differences across C1, C2 and C3. Then by definition, C is equal to Q upon V or V is equal to Q upon C. So V1 will be equal to Q upon C1, V2 will be equal to Q upon C2, V3 will be equal to Q upon C3. If we add them, V1 plus V2 plus V3, because potential is added, is equal to Q common 1 upon C1 plus 1 upon C2 plus 1 upon C3. Equation number 1. Also V is equal to Q upon CS. The CS is the capacitance of the series combination, total capacitance. So then by definition, same definition, if Q is the total charge, CS is the total capacitance, so V will be equal to Q upon CS. If we compare these two equations, we get 1 upon CS is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. It means when a number of capacitors are connected in series, charge on each capacitor remains the same, whereas potential difference across each capacitor will be different. Therefore, the total capacitance of the combination in series is given by this formula. That is, reciprocal of the capacitance of the series combination is equal to the sum of the reciprocals of the individual capacitances. Then parallel combination. When number of capacitors connected in parallel between A and B like this, let C1, C2, C3 again, capacitance of three capacitors Q1, Q2, Q3. Now charge will be different on different capacitors because potential difference remains the same. If V is same, capacity is different, Q will be different. So V is the total potential difference between A and B. Then by definition, same Q1 will be equal to C1V, Q2 is equal to C2V, Q3 is equal to C3V. If we add them, Q is equal to Q1 plus Q2 plus Q3 is equal to C1 plus C2 plus C3 into V. Also Q is equal to CPV. CP stands for capacitance of this parallel combination, total capacitance of parallel combination. So comparing to 1 and 2, again we have Cp is equal to C1 plus C2 plus C3. It means in parallel combinations, capacitances are simply added. Total capacitance of the parallel combination is equal to sum of the individual capacitances. So these formula will be used to solve problems of combination of capacitors. Then we have to derive expression for a capacitor, parallel plate capacitor, especially when there is air medium between the plates, air or free space. So simple expression for a parallel plate capacitor or for air capacitor you can see. Suppose P and Q be the two plates. P is positively charged, Q is negatively charged. Q is the total charge on each plate, magnitude of charge, A is the area of cross section of each plate, sigma is the surface charge density of the capacitor. Then by definition, if there is P is positively charged, Q is negatively charged, there will be electric field from plate P to plate Q. Let E naught is the electric field between the plates. Then by definition we have proved it. E naught will be equal to sigma over epsilon naught using Gauss's theorem. I have made a video for Gauss's applications of Gauss's theorem. So it is mentioned in second part of the Gauss applications of Gauss's theorem. You can watch there. E naught is equal to sigma over epsilon naught. So in the space between two positive and negative plates, parallel plates, electric field is given by sigma over epsilon naught. By definition, potential difference. Suppose V naught is the potential difference between the plates. So V naught will be equal to E naught into D, where D is the separation between the plates. Substitute the value of E naught. So V naught will be equal to sigma over epsilon naught into D. What is sigma? Sigma is equal to charge upon area, Q upon A. A is the area of cross section. So it is Q upon A epsilon naught D. Or from this equation we can find Q upon V naught. It will be epsilon naught A by D. And Q upon V naught is nothing but C or C naught you can say for air capacitor. So C naught will be epsilon naught A by D. So we can take it as also C naught. That is capacitance of air capacitor, epsilon naught A by D. It means electrical capacitance of a parallel plate air capacitor depends upon dimensions of the capacitor. More is the area of cross section of the plate, more is the capacitance. Less is the distance between the plates, more is the electrical capacitance. So electrical capacitance, it means will depend upon dimensions of the capacitor as well as it will depend upon the nature of the medium between the plates, between the two plates P and Q. So in the next video, I will derive expression for capacitance of parallel plate capacitor when a conducting slab or electric slab is placed between the two plates of the capacitors. So this is all about capacitance, principle of capacitor, series and parallel combination of capacitors, and expression for an air capacitor, so which depends upon dimensions of the capacitor. So you can watch it again. I think you will understand each and every step. So this topic is very important. So till next video, stay tuned, be happy, Sarbat Dapala.